Now that we've mirrored the geometry, we've created a closed loop profile that has new relations. The coincident 3 relations are still there, but notice that the line is twice as long as it was before. It used to end on the construction line, and now it extends to the mirrored point. This is a symmetric relation named symmetric 1. If you highlight it, you can see that it contains 2 points so that they're symmetric about the construction line. In fact, each symmetric relation on the construction line constrains the location of 2 points. The mirror operation also extended this line to the mirrored point, and it applied a midpoint relation to the construction line and the midpoint of the vertical line. So both ends of the construction line are constrained using midpoint relations. The sketch is fully constrained, so we're ready to revolve the profile about the construction line. Click the Exit Sketch command. Make sure Sketch 1 is selected, and then click the Revolve Boss Base command. I'll refer to this command as the Revolve command from now on. When you click the command, the view changes to the trimetric view. The axis of revolution window is highlighted in the Property Manager, so the next step is to select the axis of revolution, which is the vertical construction line. Click the line, and the preview of the operation appears in the graphics area. If you look in the axis of revolution window, you can see that line 1 that was drawn in sketch 1 is the axis of revolution. If you recall, the first line drawn in the sketch was the vertical construction line, so this line is line 1, and it was drawn in sketch 1. Set the angle of revolution to 90 degrees so that you can practice using the other settings on the Property Manager. The default direction is clockwise, but you can reverse the direction by clicking this button. The midplane option revolves the profile an equal amount in both directions. Change the setting back to blind and then check the direction 2 box. When you use this option, you can specify the angle of revolution in both directions. Uncheck direction 2 and I'll give you a quick introduction to thin features. Check the thin feature box and then set the thickness to 100,000ths of an inch. This creates a 100,000ths thick wall around the profile and then revolves it to create a hollow pulley. Notice that the wall extends to the outside of the sketch profile. The area inside the profile will be hollow. You can change the direction of the wall by clicking this button. Now the wall is inside the profile. You can also use the midplane option, which centers the wall on the sketch profile. And you can specify the offset of the wall in both directions. T1 is the thickness of the wall on the outside of the profile, and T2 is the thickness of the wall on the inside. The total thickness of the wall will be T1 plus T2. We're creating a solid pulley that's revolved a full 360 degrees, so uncheck the thin feature option, and then set the angle of revolution to 360 degrees. Type the Enter key to complete the operation. Now we're going to add a 32,000ths fillet to all the sharp corners. Click the Fillet command. You'll get a detailed description of all the settings on this command later in the course. For now, we're going to create a constant radius fillet, and the size is going to be 32,000ths of an inch. Enter 32,000ths in the radius window, and then drag a window around the pulley. Be sure to make the window surround the entire pulley. Release your left mouse button and the right-click symbol appears on the graphics area. When this symbol appears, you can right-click to complete the operation. Right-click, type the Enter key, or click the green check to add the fillets. Now that we've finished the pulley, be sure to save your work.